today. Now, this lovely thing at the top is just a little graphic I stole, and this is going to talk to you about complex numbers. Now, you guys know about real numbers. You've used them your whole life. Complex numbers encompass all the real numbers and all the imaginary numbers. And there aren't any other sets. This is every possible value you could think of. We're just going to talk about imaginary numbers today, which you may have seen before, but I would bet that you haven't. So complex numbers, you could literally write any number in this format, which is right underneath where it says complex numbers. So this is called the A plus BI format. A is going to be just a real plain number, and whatever has an I with it, that's going to be the imaginary part. So you'll see the letter I in a lot of these questions today. Now, I just want to show you two things before we get into what I actually is defined as. But you can have a real number just like a normal number. Like if I wanted to write the number 4, I could write that. It says if B in this little format equals 0. We could write it like this. I'm going to write 4 plus 0i. Now, I would never write a number like this unless I was giving you this example, but this could just be simplified to be the number 4, but I can write it in that format, so it can be written as a complex number. If you're looking at this little diagram to describe how the complex numbers work, the real numbers, just every number you've ever seen before, we could write it in this format, and it would fall into the real number part. Now, what you probably haven't seen is imaginary, and we'll do that in 1 second, but what they call a purely imaginary number, the real part where you have A here is not going to exist because it's going to be purely imaginary, so it'll just have an I in it, and I'll just a little example, I'm just making this up. So if I wrote 0 plus 3i, 0 would be the real part, 3i would be the imaginary part. I could just simplify that to be 3i, and that is what we call a purely imaginary number. There's no separate part that's just a real number. So that's real number and purely imaginary. Now, what they call just a general imaginary number, I'm going to write to the side over here, looks something, I'm just making this up, like I could have 5 plus 2i. So this is what we would call an imaginary number. So in this little diagram they've got here, imaginary numbers have two parts to them. The 5 would be what we call the real part, and the 2i would be what we would call the imaginary part. So you're going to see all these types of numbers today, but we're going to really focus on imaginary numbers because I don't know that you guys have seen these before. All right, so here's just literally the definition of what that I is. So they literally invented I. It's a real thing. It's actually used in a lot of applications for engineering, especially electrical engineering. But it was really invented to take care of what do I do if I get a square root that has a negative underneath. So this is how it was made up. So it's called the imaginary unit, I. It's not a variable. It actually has a value. It's a complex number whose square is -1. This is two things. So a two-part definition. I squared, this is just a definition. I squared is equal to an actual real number. It's equal to -1. And kind of piggybacking on that, if I were to solve that little equation, I would take the square root of both sides. So I by itself is defined as being the square root of -1. All right, not going to be able to see this on a calculator or anything like that, bless you, because it wouldn't give you a real answer to take the square root of a negative, but you can simplify these by hand, and I promise it's not hard to do. All right, so we are going to start out, and we're just going to simplify radicals like we did yesterday. The only difference is each one of these is going to have a negative under the square root, and I just want to make a little note. You are not going to put a plus and minus symbol on any of these problems. The reason for that is you put the plus and minus symbol if you introduce the square root into the problem to like solve an equation or something. These problems all already have a square root in them, so you're not going to put a plus and minus in front of these answers. We're just going to go with what's in the problem. So no plus and minus, only if you introduce the square root into the problem. Here is how, and I just have the perfect squares, they're up on the board and they're there to the side. here is how you break down a negative under a square root. Okay, would you guys be okay? I've got negative 121 as my very first question. I'm just going to rewrite that as a product real quick as negative 1 times 121. Does anybody know, just off the top of your head, square root of 121? 11 is a perfect square. Okay, here's the deal. By my little definition up here, right? I is the square root of negative 1. So by separating these, that square root of negative 1, we would pull out an I. So that's a perfect square, if you will, in imaginary land, actually. So that just comes out as I. 121 would come out as 11. To write my answer, you're just going to put the 11 in front. So this is 11I. That's literally it. It works exactly the same way as if you would simplify a normal radical. You're just going to pull an I out in front. That gets rid of the negative. It's not considered simplified if you have a negative under your square root. Okay, so if you see like this next question, I have 3 times square root of negative 36. 36 is a perfect square. Negative 36 is a perfect square in imaginary land. So what is the square root of 36? 6, right? Okay, all you do if it's negative, this would just come out as 6 with an I attached to it. That's the only difference. You're just going to put an I with it. That takes care of the negative. Now, if you already have something in front of the square root, like I had a 3 in front of this, do you guys know what you do with that number if you take anything out? If I have a number in front and I pull something out, what do I do with these two numbers? Multiply? Does anybody remember this? Okay, totally legal. This is fine. We're just going to multiply these. So I have this 3 out here already. I'm pulling out a 6i. This will become 3 times 6 is 18, and you just have an I with it. So if you've got something in front of the radical and you end up taking something out, you just multiply them together. Now, this guy right here, 29 is not a perfect square, and it's not divisible by anything. It doesn't break down. You absolutely don't have to do this, but I got to remove the negative. So the only thing that's going to get simplified here, I'm going to remove the negative by taking an I out in front of this. That's the square root of negative 1, and the 29 would stay underneath. That's as much as I could do there. It's not considered simplified if you see the negative under the square root, so to get rid of it, you're just going to pull an I out in front. Now, if you can break down the number, that's what we're going to practice in these ones down here. Can you guys think of 2 numbers, when you multiply them together, you get 12? 4 and 3. 4 is a perfect square, right? Here's just what I do. I just try and find the biggest number on this list that'll divide into that, but it's negative 12, right? So I'm going to rewrite this. The perfect square that goes into that is 4. I just attach the negative to that perfect square. So I would write this as negative 4 times 3. That's still negative 12. Has to be multiplication. Now, negative 4 is a perfect square in imaginary land. All right, 4 is a perfect square, so that's square root 2. Negative 4, all you're going to do is when you take the square root, you just call that 2i. And then the 3 would stay underneath. That's all you have to do. I don't know if anybody knows this. Does anybody know the biggest number on this list that would go into 108? It's actually 36. This is, I'm going to rewrite this real quick. 36 times 3. I'm just going to attach the negative to the perfect square. So that way when I take the square root, I'm just going to remove the I right with that. So square root of 36, that's negative. We actually just did this in the question right above. This square root of negative 36 would come out in front as a 6i, and the 3 would be left underneath. That's all you have to do. And then I got one more. This does have a 2 in front of it. Anybody know biggest perfect square on that list that would divide into 54? 9. Yep, 9 and 6. Okay, so I'm just going to attach the negative to the perfect square. So I'm going to do negative 9 times 6, that's 54, negative 54, sorry. Now, 9 under a square root is 3. Negative 9 under a square root just comes out as 3i. I do have a 2 that's already in front of the radical, so anything you remove, if something's out in front, just multiply those together. 2 times 3i would just be 6i, and then this 6 from the 9 times 6, that's still under the square root. That's your answer. Is anybody seeing a question so far? It's extremely similar to what we did yesterday. We're just going to get rid of the negative by taking an I out. That's the only difference. All right, we'll do a little bit more with this in a second, but before we do that, I'm just going to have you guys add some complex numbers together at the bottom of the page and subtract. We're going to add and subtract. All right, so I've got 3 plus 6i. This is my imaginary number. To that, I want to add 4 minus 8i. Anybody have any idea how you would add those imaginary numbers together? Like, what do you think? What's your gut instinct on this? Combine like terms. Bless. Okay. You add the real parts together. So the 4 and the 3, those are like terms. Those are both the real parts. That's just going to give you 7. And then you combine the imaginary parts. So 6i minus 8i, it's literally just 6 minus 8. So it would be negative 2, and it would have an I attached to it. It's just like combining like terms. Exactly right. Add the real parts together, add the imaginary parts together. That's your answer. If you're subtracting, I'm not trying to be annoying, but I just want to do one quick step. If you are subtracting, you have to make sure whatever imaginary number you're subtracting, you've got to subtract both parts, the real part and the imaginary part. So in terms of the subtraction, I'm just going to drop, there's no reason for me to have parentheses around that 9 plus 7i, so I'm just going to drop the parentheses there. It's very important, though, the number I'm subtracting from that, I have to subtract both parts. So just think about that as distributing like a little -1. So this would become minus 2, and then negative times a positive be minus 5i. Then once you're there, it's exactly like the question we just did. We're just going to combine like terms. So your real parts get added together. I've got a 9 and a -2, and we'll combine those. And then we've got our imaginary parts, the 7i and the minus 5i. So 9 minus 2 would just be 7. And then 7i minus 5i would be plus 2i. And that would be as simplified as I can go there. You just add the real parts, add the imaginary parts after I distribute the little subtraction symbol. Does anybody have a question? All right. Now, same problem, just written in a teeny tiny bit different format. So just to practice some more with the square roots, I have 2 plus and then -16 under a square root. What would -16 under a square root really simplify to be? 4, how do I take care of the negative? 4i, right? Okay, -16 is the perfect square in imaginary land, but the square root is 4i. Okay, notice I didn't change the sign in front of that or anything. It was 2 plus that, stays 2 plus that. Okay, in between here, I'm adding. You could just drop the parentheses if you're adding, because we're just going to combine like terms. Now, this is 8 minus, so that's not going to change. What is -25 really if I simplify it? 5i, exactly. So once you're there, then you're just going to combine like terms. So I'm going to take the real parts, add those together. I got a 2 and an 8. And then I'm going to take my imaginary parts and add those together, just like combining like terms. 2 and 8 just gives you 10, right? Okay, for the i's. You have 4 minus 5, so that would be -1. Typically, you're not going to see a 1 written in front as a coefficient, so that would be written as just -1i or just -i is how we would write it. All right, and I got one more. This one is subtraction. So in the first set of parentheses around that imaginary number, I'm just going to drop the parentheses. It doesn't have anything in front. What would you write as the real value of the square root of -1? I. That's the actual definition. I is the square root of -1. That's the actual definition from the front. Now, for the second part of this, I am subtracting. So I'm just going to distribute the subtraction symbol here. So this would end up being -3, and then it'll be a negative times a positive there. So I'm actually going to change that to a minus. What would the square root of -64 really be? 8i. All right, and then once I got that, just combine your like terms. So the real numbers get added together. So I've got a 6 and a -3. So that would just give me 3. And then the imaginary parts get added together. In this case, I've got negative I and negative 8I. How many i's would that be? Negative 9, exactly. And that's it. Is anybody having a question about adding or subtracting? Okay, now we're going to go over multiplying here real quick. And I just want to remind you of part of the definition of I on the front because we're going to run into this here. All right, I squared, which we're going to end up with because we're going to multiply some things together here. I squared by definition is equal to -1, an actual real number. So some of these are actually going to not have any imaginary parts when we go through them. So you just multiply these like you would multiply, I've got 3i times 8i. You multiply that together just like you would do like 3x times 8x. So just going to multiply your numbers. So 3 times 8 is 24. And I times I would turn into I squared. The major difference with I and like a normal variable is I squared actually has a value. So this is really 24 times -1. And then all the imaginary parts are going to cancel out here. My answer is just going to end up being -24. Totally legal. If you square an imaginary number, which I'm going to do right next to this, -5i squared would be -5i times -5i. So just multiply the numbers. -5 times -5 turns into +25. And very similar to the last question, I times I becomes I squared. Just different than a variable. I squared actually has a value. It's equal to -1. And so 25 times -1, the final answer there would end up being -25. Is anybody having a question about that? Is it snowing right now? It is snowing right now. Cool. Okay. Sorry, I didn't mean to. Sorry, I just distracted everyone. My fault. All right, it's probably construction debris. Okay. I'm going to multiply. These are a little different format. They've got two pieces. So I've got a real part and an imaginary part here. And if you guys are going to multiply these together, all we're going to do, we're just going to treat this like a little foil. Or a box. If you want to draw yourself a box, you can do that here too. I think I've mentioned this to you guys before. I just think of this as a double distributive property. So I'm going to do 3 times both terms in that other imaginary number, and then -7i times both terms in that other imaginary number, and then we're going to combine like terms. So 3 times -2 is -6. 3 times 6i is 18i. -7i times -2 ends up being +14i. And then -7i times 6i, do -7 times 6, that's -42. And then I times I turns into I squared. Now the tricky part, if you end up with I squared, don't forget, just like we did in those last couple questions, I squared actually cancels and becomes a real number. So this last term here would be -42 times -1. If I do multiply two negatives together, that term on the end is actually 42. All right, so that last term on the end, that -42i squared, is really equal to +42. What you want to do, just combine like terms. So I'm going to add my real numbers together. And it should go in the format, the a plus bi. So the real part is supposed to go first and the imaginary part is supposed to go second. So the real part would be -6, and I'm going to add 42 to that. So that would actually just be 36. And then my imaginary parts here, I have 18i and 14i. Just add those guys together. 18 and 14 is, what is that, 32? Yeah, 32i. And this would be my answer. So it's just going to work like a foil. And I have one more. This is also just going to work like a foil, but this is a little bit of a weird problem. So these two imaginary numbers I'm going to multiply together. They're almost identical. The one difference is one has a plus and one has a minus in between the terms. Otherwise, they're identical. All right, so let me go through and multiply this real quick. 11 times 11 gives you 121. 11 times that -4i is -44i. Now, because these are identical except for the sign in between, what's going to happen here? In the middle, 4i times 11, I'm going to get plus 44i. So in this case, these guys in the middle actually cancel each other out. So those would add up to 0. I've got a negative 44i, positive 44i, combine those at 0. I still have the 121. Now, on the end here, positive 4 times negative 4 is going to be negative 16. And then I times I, remember that gives you I squared. Now, this term on the end, I squared, becomes a real number. This is really negative 16, and then I squared by definition is negative 1. So the term on the end here is actually positive 16. Now, I don't have any go ahead. 3 here times the 6i here. Right? Is that right? 3 times, yeah, 3 times 6 is 18. Yeah, we're good. Oh my gosh, I just second guessed that. I'm pretty sure that's right. So 3 times, that's the 18. Negative 7 times negative 2, that's where I got the positive 14. And then negative 7 times positive 6, that's negative 42, and then you got your I squared. We should be okay. All right, just checking. All right, now, my real parts here. All right, we're almost done. Okay, my real parts. I got 121 and 16, so I'm just going to add those guys together. The answer to this question is just a plain number. It's 137. The imaginary parts all canceled out on that question, so that can happen. Okay, now, here is the entire purpose of showing you guys imaginary numbers is so we can solve quadratic equations that have imaginary answers. So that's what I have at the bottom here. Huh? Yeah, we didn't have imaginary answer. That's what we did yesterday. But we're actually going to answer the question today. So I'm going to get x squared by itself. What we're going to end up with that we didn't end up with yesterday being able to answer is a negative under the square root. So I'm going to get negative 48 here when I subtract that from both sides. Don't take the square root until you get the x squared all alone. This would be negative 24. Okay, now, sorry, I should have written this. When you guys solve these equations at the end, I do need to use the plus and minus symbol because we're going to end up introducing a square root into the problem to help us get rid of the squared. So we do need the plus and minus. You don't need it if you already see the radical in the problem. Okay, let me come over to the side here. So I got to break down that 24. Biggest perfect square that'll divide into 24 is 4. So like I was telling you on the front, I just attached the negative to that perfect square, and I'm just going to break this down. Negative 4 under square root is going to come out as 2i, and then I'd still have the 6 underneath. Negative 4 times 6 would give me back that 24. So my answer to the question, I introduced that square root to the problem, so I got to have that plus minus. It's two different answers, just a little shorthand way of writing it. This would simplify to be 2i times the square root of 6. Yesterday, if we had this problem, we would have written no real solution, which is still true, but this has two imaginary solutions, which is what's going on in this question right here. All right, and I have one more. Remember, don't FOIL. If you guys have an equation you're solving and you've got like a set of parentheses that's squared, don't FOIL. You want that because we can get rid of the squared by taking the square root. We just have to get it by itself. So get rid of any addition or subtraction first. I'm going to move that 60 by subtracting it. And that's going to cause us to end up taking the square root of a negative here in a second. But I'm going to subtract 60 from both sides. Don't multiply by 3. Don't distribute. We're going to divide. We're trying to get that set of parentheses alone. This is going to end up giving me negative 20. And then don't FOIL. We don't want to do that because we can just cancel this whole thing out by taking the square root. Now, this will have one extra step the question we just looked at does not have, but this will have, instead of a plain x, we'll have x minus 2. The square root and squared cancel each other out, but I still have the x minus 2. And then I'm just going to break down the 20 over here to the side real quick. 20, biggest perfect square that goes into 20 is just 4. If I'm trying to break down negative 20, I'll just write that as negative 4. So this would be 2i square root of 5. All right, so I introduced that square root to help me solve it. So I got to have the plus minus because there's two answers here. This would be 2i radical 5. Now, to get x totally alone, just one more step, I'm going to move this 2, so it's x minus 2. I'm going to add 2, just like I was telling you yesterday. Just write that right after you write the equal sign, and then plus minus 2i radical 5. And I know that looks like a garbage answer, but that's just how it is. That is a garbage answer. If you actually would plug that back in for x, that would make that equation true, but you can't actually add or subtract that because that other number's got a radical and it's got an imaginary piece to it. So that would just be how we would want to leave that. Is anybody having a question?